Okay, my next demo is a decomposition reaction. And a decomposition reaction is just what it sounds like. It is a single compound that decomposes or breaks apart, breaks down into simpler substances. So what we're going to decompose is hydrogen peroxide, which is in this weird looking bottle right here. Okay, I want to talk for a second here about why it's in this bottle. You probably have hydrogen peroxide in your home. It is probably in a bottle that is that same brown or black color, but it doesn't have this funny shape to it. This is what's called an accordion bottle for obvious reasons. And the reason it has that shape is because this hydrogen peroxide is about 10 times more concentrated than what you have at home. This reaction that I'm about to show you takes place slowly over time, especially when hydrogen peroxide is exposed to light. That's why you put hydrogen peroxide in a dark bottle like that, so it doesn't get exposed to light. This hydrogen peroxide, because it's so concentrated, when it decomposes, it releases a gas. And so this bottle, when you first buy this stuff, it's all scrunched down. It's it's all those accordion fins that are all squished together, and it's a really short, squat bottle. But over time, as this decomposition reaction happens spontaneously, sitting on the shelf in the storage area, that gas is released and that bottle is allowed to expand. Otherwise, the bottle might explode, which that would be bad. What I'm going to do is I'm going to put some of this hydrogen peroxide, I've already got it measured out in the little graduated cylinder here. I'm going to put this into the large graduated cylinder. Okay. And I'm going to add a little bit of dish soap. It's not really part of the reaction, but it makes it look a lot cooler. And I'm also going to add a little bit of food coloring for the same reason. Not really part of the reaction, but it makes it look kind of cool. So put some red in there, put some blue in there. Hopefully we'll get a purplish color. Go Riders. And I'm going to slosh that around a bit. Okay, looks kind of gross. All right. So this, like I said, this reaction will take place on its own, but it's very slow. It takes place over weeks or months. I'm going to try to get it to go here within just a few seconds. And to do that, I'm going to add what's called a catalyst. And you might have heard that term before. A catalyst is a substance that speeds up a chemical reaction or allows a chemical reaction to occur, but doesn't really participate in the chemical reaction. So the catalyst I'm about to use is sodium iodide, but that is not in the chemical equation as a reactant or a product. It's just simply something that speeds up the chemical reaction. So here we go. I'm going to go ahead and pour this in here, and we'll see what happens. Look at all the steam coming off of it. Obviously lots and lots of foam. I'm also going to try something here. I'm going to light a wood splint, and I'm going to just kind of poke at the bubbles a little bit and see if you can notice anything about the flame when I poke into the bubbles. Notice how it doesn't put the flame out. The flame actually kind of flares up a little bit. The gas itself is not really igniting, okay? But it's also not putting the flame out. It causes the flame to kind of flare up a little bit. So hopefully that's a little bit of a clue as to what that gas is that causes those bubbles. Also remember that hydrogen peroxide is H2O2. That's the chemical formula for hydrogen peroxide. That's the only reactant. And remember, the products have to be made out of the same substances, the same elements, and the same number of atoms of those elements as the reactants do.